For our next chapter, we will revisit the concept of reflection and then apply that to mirrors. So remember that the law of reflection was the angle of incidence equals the angle of reflection. And I have a surface drawn for you right here. Remember that we want to measure our angles from the normal line, which is this imaginary perpendicular line. And our angles are measured outward from the normal line. So this would be our angle of incidence. And then our angle of reflection would be measured right here. And the reason that we do that is because you may not always have a flat surface. It might be jagged or curved. However, a normal line, or that perpendicular imaginary line, will always give us a standard reference point from which to measure our angles. Now we're going to look at two types of reflection. The first one is called specular reflection, and it's the one that you're probably used to so far because it is caused by a smooth surface. So you can remember that specular and smooth both start with S, so those two are going to go together. So I just gave you an example. If we have some incoming light rays, okay, they are going to reflect parallel to each other. So the incident light rays are definitely parallel to each other. And because we have this flat surface, the reflected rays, which are my lighter green ones, are going to reflect in parallel with each other as well. So you can take a moment and pause and draw that picture on your notes. The second type of reflection is called diffuse, and it is caused by a rough surface. So this would be some sort of jagged edge that's not going to be a smooth surface. Our incident light rays are still parallel. Those are my dark blue ones, just like I did on the previous slide. So the incident ones, you can see the arrows are going toward the surface. They are all parallel to each other. However, the reflected rays are not parallel. They're getting scattered in all different directions. So your picture in your notes doesn't have to be exactly like mine, but you do want to have the incoming or incident light rays parallel to each other, and then your reflected light rays are going to reflect off in all different directions, so they are not going to be parallel. So take a moment and draw a sketch in your notes. Next, we're going to talk about the two types of images that we will see reflected in mirrors. The first one is called a real image, and its definition is an image formed by actual rays of light. So we're physically going to get light rays to cross each other and produce that image. You can recognize a real image easily because it's upside down or inverted. This will probably be the most defining characteristic and the easiest one for you to recognize. And then because we have actual light rays crossing each other to produce this image, we say that it's formed by the converging of light rays. That means our actual rays are going to cross each other. The other type of image is called a virtual image. Its definition is one in which the image only appears to be formed by rays of light. You can recognize it because the image will be right side up or erect. So like when you look in a normal mirror in the morning, probably when you're brushing your teeth or you're getting ready for school, and you see yourself right side up, that would be a virtual image. This type of image is formed by the diverging of light rays, and it's always on the opposite side of the mirror from the object. So when you're looking at the mirror when you're getting ready in the morning and you see your image, you kind of get that depth perception. So if there's some space between you and the mirror, you'll see that same space represented in the reflection as well. And we are going to revisit these, but for right now, you need to know that there are two types of images, real and virtual. Which one is right side up and which one is upside down. Those will be the easiest way to distinguish those two. Next, we're going to talk about different types of mirrors. For this lesson, we're only going to visit plane mirrors, and then the curved ones we'll talk about in a future lesson. So a plane mirror, notice the spelling of it, that just means a flat, smooth surface. And if we have a plane mirror, the flat, smooth surface from which light is reflected will reflect in the form of specular reflection. So all of our incident light rays and reflected light rays are going to be parallel. And for the plane mirror, all parts of our image are equidistant behind the mirror. This is a really important word that you're going to see come up. So equidistant. On the previous slide, I mentioned that when you look into a mirror when you're getting ready in the mornings, if there is some space between you and the actual mirror, you see that distance in the reflection as well. So we get that depth perception for a plane or a flat mirror. So what I've done here is this line represents the plane or the flat mirror, and then I've got 3 points of a triangle labeled. Now when we say this word equidistant, that means if I were to measure from the mirror out to point A, that distance would be the same as from the mirror to where the reflection of point A appears to be. And I could do that with each of the 3 points. So if I were to measure from point B to the mirror, the reflection that I see for point B appears to be that same distance back. And then for point C, we could do the same thing. From C to the mirror would be the same distance as where C appears to be in the reflection in that mirror. So in a sense, what we get when you see an image reflected by a plane mirror, it's still upright. The A is still at the top. However, the left and right are flipped. So if you've ever looked in a normal mirror and you have writing on your t-shirt, when you look at the reflection, that writing will appear to be backwards. So it gets flipped left to right, but the up and down are still going to be the same. And lastly, I have a question for you. If you were to stand in front of a full-length mirror, and we're assuming that you're far enough back where you can see head to toe, I want to know the minimum size for that mirror to be for you to see your head and your feet included in that reflection. So take a moment and see if you can guess correctly what you think that is going to be. Okay, this will be a test question, so I hope you answered correctly. You should have gotten the answer that the mirror only needs to be half of your height. And the reason that we do that is we look at the law of reflection. So if I have light rays bouncing from my toes to the mirror, and I were to draw a normal line in, that incident angle would equal the reflected angle, and those light rays would be able to reach my eye. So in essence, I don't even need this part of the mirror at all. And the same thing from your head to your eyes, you don't need that top part of the mirror. So what's left over ends up being half of your height. And remember, this is a test question, so everyone should get at least 2 points on the next test. That's it for today. Next time, we will talk about curved mirrors.